our discussion is about now. Simply, from the table, you are able to conclude that a shock can be experienced when there is a potential difference existing between one part of the body to the another part of the body. So, without a without a potential difference, the amount of current passing through your body will not be allowed. That energy gap compulsory, right? Higher potential difference to lower potential difference, that charge starts to move, passing, right? So, are you clear about that electric shock? Are you clear about that? Use a quick reaction or raise your hand if there is any doubt. Okay, so now just simply we are moving to another one, that is simply, okay, potential difference is required, then resistance is affecting the amount of current, right, passing through our body. And one more you need to observe here, the body resistance is same throughout the body. Human body resistance remains constant every point of or any part of your body. No, because here your body wet inside comparing with the external part, skin, right? So the body resistance is not same, right? The body resistance is not remains same, and once the current set to pass through your body, the body resistance further decreases and the current amount increases slowly in your body. So that can see the person inversely proportion, right? They are inversely proportion. Then the question is it the effect of voltage or the current? So what we can answer? It is the effect of voltage and current. To allow the current through your body, potential difference must, once the current is passing through your body, resistance changing. So resistance changes, amount of current increases. That amount reaches to maximum 0.07 amperes. It can be said to be fatal dose. So amount of current is deciding. Amount of current is deciding that effect on your body. Right? So that kills the person. So it's said to be combined effect. It's said to be combined effect. Underline that. Right? So this is, you need to understand. Electric shock is combined effect of a potential difference and electric current and also resistance. If the resistance do not vary, what happens? The amount of current will not change, right? So that also affect combined effect of three factors. V equal to IR simply. V, I, R. The three are affecting the electric shock, right? So here there is one interesting question, right? What is that? Simply the bird sitting on the electric wires, main wires on the pole, right? But do not felt any shock. Can you guess the reason for this? Simple. Here what we decided previously, electric current is combined effect of voltage, current and resistance. So here simply where the bird is simply sitting on single wire. The bird is sitting on a single wire. So once it sits on the single wire, what happens? There is no potential difference between the legs of the bird. V equal to 0. No potential difference. V equal to 0. If there is no potential difference between the parts of the body of a bird, no potential difference or no energy gap, right, between the parts of the body, then what about the amount of current through that body? I is equals to also 0 here, right? I is equal to also 0, right? So no importance to the current, no importance to the voltage. So do not get shocked. Once, if unfortunately, if it is come in contact with the another wire of the pole, then what happens? That potential difference will be generated or created between the legs of the bird if it is in contact with the two wires, right? So that one wire is said to be phase and the other wire will be said to be neutral, right? So empty wire. So there is energy gap, right? So that allows the current through, but only the potential difference. So potential difference is created, then automatically I value increases, R value decreases, right? So this happens, then the bird gets shocked. So why not it getting shocked? There is no potential difference between the legs of the bird on one pole, right? So it is sitting on one wire. So that is the reason. So here you are using the devices to measure the resistance, current, and voltage, right? I am not mentioned about resistance measuring tool, right? So that resistance measured by a device called a ohmmeter. Which device is used here? That is ohmmeter, right? So here ohm meter is used to measure the resistance in ohms. Current is measured in volts by using the voltmeter. Sorry, voltage is measured in volts using voltmeter. Current is measured in amperes using ammeter. So here simply you required ohm meter here, voltmeter here, and ammeter here. So all these three measured by only a single device called a multimeter, right? Multimeter, that is on the screen here left side. So here this device is called a multimeter. It has display, right? Digital display. Then it has selection knob, right? Selection knob and the ports, right? So display, selection knob and ports. So here ports are available in two colors, red and black. Red always connected to milliampere volts, milliampere volts, right? So ohms also there, right? Milliampere volt ohms. So this is right. So this will be connected with the red port. Then it is connected, black colored port connected to common, right? That is connected to common. So here if you want to measure anything, just you need to change the selection knob, right? So if you set up that selection knob for amperes, it can measure the current. If you select that selection knob to the ohms, it can measure the resistance. If you select that selection knob to show that volt, automatically then it will measure the voltage. So single device working like three devices, right? So that is called multimeter. This is about a multimeter, right? So this is about the information related to today's